Very good afternoon to one and all present here. Uh, Welcome to the second session of GATE 2023 training program. This session will be on engineering mechanics. So here we are going to discuss few aspects related to engineering mechanics. First of all, myself, Arjun V, working as assistant professor in the Department of Civil Engineering from last 8 years. In this session, we are going to discuss very few basic aspects of engineering mechanics, which is very essential to crack the GATE. So syllabus consists of engineering mechanics, in the engineering mechanics, the system of forces, free body diagrams, equilibrium equations, internal forces in structures, friction and its application. So friction and its application, you can expect few questions related to friction chapter in engineering mechanics. So generally in engineering mechanics, the subject, it will be asked in the application level, not at the very basic level. It will be the questions will be asked for at the applications level. So you have to be very good in fundamentals, then only you can solve the problems of engineering mechanics very easily. And center of mass, free vibration of undamped single degree of freedom system. This is the syllabus. In this presentation, I am going to discuss few aspects related to engineering mechanics, basic principles and assumptions in the engineering mechanics, equilibrium for coplanar and concurrent and non-concurrent force system, free body diagram, friction, few basic aspects of friction, and we will solve few numerical problems. Then we will summarize the entire aspect what we discussed in the today's class. So coming to the introduction part, the very first basic idealization what we do in engineering mechanics is rigid body. So what is rigid body? If a body, while analyzing the body, if the position of the 2 points in any body, if the position of the any 2 points in any body when subjected to force changes, then it will be called as deformable bodies. If the relative position does not changes, then it will be called as rigid body. So in engineering mechanics, in order to solve the problem very easily, this we will assume the body to be a rigid body. So example for rigid body, you can consider as rocks, and deformable body, you can take the example of sponge. If you apply a force on the sponge, the relative position of the sponge is going to vary. So in case of rocks, the relative position will be almost constant. So that's why it will be considered as rigid body. So our entire engineering mechanics is based on the Newton's law, depends upon Newton's law. In order to analyze the problems, we should know certain basic aspects. So the first law, generally it is called as law of inertia, which states that the body will be in the state of rest or in the state of uniform motion unless otherwise it is altered by some external agency called as force. So if the body is in, that will be the first law of inertia. So body remains in state of rest or in the state of uniform motion unless it is affected by an external agency called as force. So that is first law. Second law states that the force on a body is always directly proportional to mass into acceleration, where mass is generally a constant parameter. So we will consider F is equal to ma. Newton's third law, it is a very well-known law. So for every action, there is an equal and opposite reaction. So based on these Newton's laws, we are going to analyze the entire force and force system. Along with that, Newton's law of gravity is also a very important law. So the Newton's laws of gravity says that the force is always, if the force of attraction between any two objects, if you consider, it is always proportional to product of the mass of two objects, uh, product of mass of two objects and the square of the distance between them. So that is the Newton's law of gravity. So if you take out the constant will be considered as G. Next very important law which is required for analysis of problem is principle of transmissibility of forces. So which says that on a rigid body, if you apply a force, if you change this force, if you change the force F along the same line of action of force anywhere on the body, then the effect remain same. That's what principle of transmissibility of force. That means if you want to, in order to simplify few parameter, you can change the position of the force along the same line of action of force anywhere on the object. So but the effect on the object will remain unaltered. That's what principle of transmissibility of forces says. Next is principle of physical independence of force. So which says that if n number of forces is acting on the object, then the effect of individual force is unaltered by another set of forces acting on the body. For example, if you consider this object, let us, for an instance, if force F1 is acting, then it produces an acceleration A1. If I assume like that, if I replace it by force F2, it will produce an acceleration of A2. So if I apply both the things, the force F1 will accelerate by magnitude A1 and force F2 will accelerate by magnitude A2. So that means even though if number of forces are acting on the body, there will be physical independence will be there on each force. That's what principle of independence of force says. Next is principle of superposition of force, which says that if number of forces is acting on a object, say let us consider a rigid body. If I apply a force F1, it will accelerate the object by A1. If I replace it by F2, it will accelerate by A2. So if I apply both F1 and F2, the effect of acceleration will be combination of both force F1 and F2, that is A1 and A2. So that will be the principle of superposition of forces. So these are very basic principles that we need to remember in order to solve the problems related to engineering mechanics. So next move on to the resolution of force. So resolution of force is done in order to simplify the analysis. So if there are n number of forces acting on the object, in order to analyze it, for simplification purpose, what we do is we resolve all the forces into two perpendicular axes. Generally, it will be x and y. Certain times, as the problem demands, we might have to change the coordinate axis. Generally, with respect to two perpendicular axis, we will resolve all the forces into horizontal and vertical component, and then we will solve the problem. Depending upon what they have asked in the problem. So how to resolve the forces then? So generally, while resolving the force, always write the coordinate system on each force, write the free body diagram of each force, and write the coordinate at the tail end of your force. Okay, so the tail, if you write the tail end of your tail end at the right, if you write the axis or reference axis at the tail end of your force, you will came to know on which quadrant it is acting. Okay, so if it is acting in the first quadrant, both the x component and y component will be positive. If it is acting in the second component, x component will be negative and y component will be positive. If it is acting in the third quadrant, both the x component and y component will be negative. If it is acting on the fourth quadrant, it will the x component is positive and y component will be negative. So like this, we are going to consider the sign of the forces in order to simplify the problem. Then we can we can find out the resultant and direction of the resultant force in the later stages. Okay, so resultant is a force which produces the same effect as a single which produces the same effect as the combined which produces the same effect as the system of forces. A single force will be called as resultant force. So generally, in order to find the resultant force, what we are going to do is we are going to resolve the entire force system into horizontal and vertical component, and we will take the summation sigma fx square plus sigma fy square under the square root in order to get the magnitude of the resultant force. So that's how we are going to find out the resultant force. And in order to find the direction of this, say example, if you consider this diagram, in this diagram, the force F1 is in, if you write the reference axis, horizontal and vertical axis on the tail end of the figure F1, it will comes in second quadrant. Okay, it will comes in second quadrant. If I know the angle with always measure the angle with respect to x-axis. If you know the angle with respect to x-axis, the x component is always equal to f cos theta and y component will be always equal to f sin theta. Even though if they given the angle with respect to y-axis, you take the angle with respect to x-axis by taking 90 minus theta. Okay, so then your x component will be always f cos theta and y component will be always f sin theta. So if it is in the first quadrant, the fx component will be fx cos theta 1 and fy sin theta 1. Since both the component are positive, we have to take the symbol as plus. So plus symbol indicates the positive direction. Whatever the force acting towards right is considered as positive in case of horizontal forces. In case of vertical forces, the force acting upward will be considered as positive. So in the second quadrant, the y component will be positive, but the x component is on the negative side since it is acting towards left. Okay, so like that, we are going to find out the x component and y component of the forces, and then we are going to find out the resultant force and its direction if I know the magnitude of each force and angle which is acting with respect to x-axis. So these are the few basic aspects related to engineering mechanics. So coming to the equilibrium condition, so we know that equilibrium is nothing but it is a state of rest. So an object is said to be in the state of rest in case of concurrent force system. Concurrent force system, basically the entire force system is divided into two categories: coplanar and non-coplanar force system. Again, in coplanar force system, there will be a concurrent and non-concurrent force systems acting on the plane. So coplanar is nothing but if the number of forces, two or more forces acting on a single plane, it will be called as coplanar. If a number of forces is not acting on the body not on a single plane, will be called as non-coplanar force system. If the forces are all the line of action of force meeting at a single point, then it will be called as concurrent force system. If the line of action of force does not meet at a single point, then it will be called as non-concurrent force system. So, and in case of concurrent force system, in order to maintain an equilibrium, so the necessary conditions are sigma fx should be equal to 0 and sigma fy is equal to 0. In case of and certain times rotation also comes into picture. So sigma mz is equal to 0. In case of non-concurrent force system, there will be 6 conditions sigma in order to maintain the state of rest. The net force in the x direction should be equal to 0, net force in the y direction should be equal to 0, and the net force in the z direction should be equal to 0. Along with that, the rotational moment about any axis should be equal to 0. So it may be with respect to x axis, with respect to y axis there should not be any rotation, or with respect to z axis there should not be any rotation. So that is the necessary condition for an equilibrium. So the best example in order to explain the equilibrium of non-concurrent force system can be taken as rubrics. So this rubric cube can be rotated in x, y and z direction. If the rubrics is said to be in the equilibrium, the net force, it should not move in the x direction, it should not move in the y direction, it should not move in the z direction, and also the rotational, it should not rotate about x axis. If you consider this as this picture, the third picture, it is rotating about the y axis. It is in the next picture, it is rotating about perpendicular to the board surface. It is with respect to z axis, or else it should not rotate with respect to y axis also. So that is the basic equilibrium condition that we have to consider. So the equilibrium condition for a force system should be equal to in order to maintain equilibrium, the necessary conditions are sigma fx is equal to 0, sigma fy is equal to 0, sigma fz is equal to 0, and mx, my and mz should be equal to 0. Next important aspect is free body diagram. So free body diagram is a graphical representation of a single or subsystem of bodies which is isolated from its surroundings but shown under the action of force. So when we want to highlight the object by isolating the unwanted material, that representation which is represented in terms of graph is generally called as free body diagram. So in engineering mechanics, so the very objective is to analyze the forces. So here the force will be our important aspect. Okay, so here if you consider this picture, a kid is playing the swing. So here the swing is fixed at both the ends and kid is sitting on a plank and playing the swing. So here the ropes are subjected to tension, and if weight of the kid is acting at the plank portion, so these forces are here. By isolating the kid and plank portion, we have represented the forces acting on the body. So this type of system are called as, this type of diagram are called as free body diagram. So similar sort of example in case of cranes. In order to lift the object, cranes are used. So here the forces is experienced by several members. So those members are represented and the forces are represented here. Similarly, in case of ladder resting leaning against the wall on the wall surface, the forces acting are, there are two contact surfaces, so there will be a reaction on this, and from the wall surface also there is a two contact surfaces, there will be two reaction, and there is also a friction of the ground comes into the picture. So these, if you represent this forces, if you represent these forces by isolating the surroundings, then such a type of diagrams are called as free body diagrams. So we'll solve few problems related to basic problems which is generally asked in the GATE examination. So generally there will be in case of resolution and composition of forces, they may ask you to find out the uh, resultant of the forces by giving the some magnitude. So let us solve one or two problems related to force systems. So the first problem saying that two forces of magnitude 2p and 3p act at an angle of 60 degree to each other. So the resultant force is dash. So these type of questions are generally asked for 1 marks. If you want to, so this type of problems are generally asked for 1 marks. Here, in order to solve the problem, they have mentioned that there are two forces. Say example, the magnitude of two forces P and 2P. Sorry, 2P and 3P. So 2P and 3P. Okay. So the angle between the two forces is given as 60 degree. We need to find out the resultant force. So these type of problems can be solved by applying the law of parallelogram of forces. We know that either if we know the angle with respect to horizontal axis, we can solve this problem by regular formula. Resultant is equal to square root of sigma fx square plus sigma fy square. We can find out if I know the angle of each force with respect to horizontal or vertical. Here, the angle between the two forces is given. So I am applying the law of parallelogram of forces. So which the resultant of, in case of law of parallelogram of forces, is if P and Q are two forces, then the resultant force will be equal to P square plus 2P Q square plus 2PQ cos theta. Okay. So here the P is 2P and Q is 3P. So if I substitute that, you will get the resultant. You will get the resultant force as P and the square of root 9. So second problem, identify the correct free body diagram for a simply supported beam shown in figure. So we know that in this case, there is a one hinged support and one roller support. In case of hinged support, the reaction will be two. One is vertical and another one is horizontal. Horizontal reaction and vertical reaction. For roller surfaces, there will be always one reaction, which is always perpendicular to the surface. So, and we have to, the free body diagram means it should also include the forces. So while representing the free body diagram, in the first one, they have mentioned Rx1 and Ry1. So horizontal and vertical, what I have mentioned. So there are two reactions that they have mentioned, and one reaction at another end R2, and they have also represented the force W. In case of second diagram, at the hinged portion they have given only one reaction. So this won't be the answer. In case of third diagram, they have not mentioned the magnitude of the force here. Okay, so this is also not right, and also the reaction for the roller surface is they have considered the two reactions, one is vertical and the another one is horizontal. So this won't be the answer. So in case of D, even though horizontal and vertical reaction is there, and again extra one reaction they have mentioned, they forgot to mention the magnitude W. So the correct answer is option A. Option A is the correct answer. So before finalizing the answer, you should always double check the problems, because it is going to, there will be some problems with negative marking, so you have to be very careful. So next one, problems. The resultant of two forces P and Q is R. If one of the forces is reversed in the direction, the resultant of S, the resultant is S. Which of the following is true for identity? R square minus S square is equal to 2PQ. So here they have given the resultant. They have mentioned that there are two forces acting on the system. If one of the force is reversed, the resultant will become S. Which of the following is true for identity R square minus S square is equal to 2PQ? Forces are collinear. Forces act at right angles to each other. Forces act at 60 degrees to each other. Force can have any angle of inclination between them. So solution for this problem is, we know that in order to find the resultant using the parallelogram of forces, we have the equation R is equal to P square plus Q square plus 2PQ cos theta. Or you can write it as R square is equal to P square plus Q square plus 2PQ cos theta. So here S square R resultant for second condition, if the direction is reversed, then the equation will become S square is equal to P square plus Q square minus 2PQ cos theta, because Q is reversed, so it will become minus 2PQ cos theta. If you take R square minus S square, it will become 4PQ cos theta. Given that R square minus S square is equal to 2PQ, they have mentioned that R square minus S square is equal to 2PQ. Given equation here, the equation this will happen only when theta is equal to 60 degree. So if the theta becomes 60 degree, cos 60 degree is half, so this will become 2PQ cos theta. So the correct answer is option C, forces act at 60. A known similar type of problem, here they have asked a known force R is to be replaced by two forces P and Q parallel, and distance A and B from R as shown in the figure. Force P will be equal. So force P and Q parallel A, and its distance is A and B from R as shown in the figure. Force P will be equal to. So here we need to find out the reaction. They have asked us to find the reaction. In order to find out the reaction, what you have to do is apply sigma fx is equal to 0 or sigma fy is equal to 0 and sigma m z is equal to 0 condition is to be applied. If you apply the condition, let us consider here we need to find out the force P. So I will take the moment about Q is equal to 0, sigma mu is equal to 0, considering the moment acting in the clockwise as positive. Okay, so if I take the moment now, it will be P into A plus B, which is acting in the clockwise direction. So I will take it as positive, and minus R into B will be equal to 0. Okay, so therefore we require P. I will send remaining to that side. So RB divided by A plus B will be the equation for P. So this is how, using the equations of equilibrium, we can answer the problems directly. So option C is the correct answer. So the next important concept to be learned is friction. So friction is nothing but the force developed at the contact surface between the 2 points that prevents or tends to prevent the motion of a body over the other body is generally called as friction. So when an object is moved on when an object is moved on any other surface, or two surfaces are moved one over the other, there will be a resistance to the movement. So that force is called as friction. That force is called as friction. So friction is always uh, opposite to the direction of the motion. It is not always uh, opposite to the applied force, but it is always opposite to the direction of motion. So while considering the friction, if the frictional force is F is always opposite to the direction of the motion of the body, F is independent of frictional force is independent of area of contact. If the applied force is less than friction, the object will be in the state of rest. If the applied force is just equal to the friction, the body is just going to tend to move. If the applied force is greater than frictional force, the body will start to move. So in the friction, there are two types of friction. So if you apply a small force, if you consider a block, if I apply a force P of small magnitude, initially it will not move. If you keep on increasing the load or a force, at one point of time, it just starts to move the object. So that point is called as limiting friction. So limiting friction is nothing but it is the point at which it is the maximum friction which is exhibited by the surface at the time of just body tending to move. So that is called as limiting friction. So dynamic friction means even though object is moving, the surface will offer a certain amount of resistance to the movement. So that friction will be called as dynamic friction. So the dynamic friction is generally always less than the static friction. Okay, so it is always less than the static friction. So another important terminology is what we use in case of friction is angle of friction. So angle of friction is, so when we consider a force, when we consider an object, if it is subjected to various types of force, when it comes in contact with the surface, there is always a normal force perpendicular to the surface. The angle between the normal force and the resultant force will be generally called as angle of friction, and the tan of angle of friction will be generally called as coefficient of friction. Next is angle of repose. So when you place a body over an inclined surface, on a horizontal surface, generally it won't move. Okay. So when you start to tilt the object, slightly, by say example 1 degree, in such a case, if the frictional force is more, it does not move. Okay. So if you keep on increasing the angle of inclination, at one point of time, the body just overcomes the frictional force and starts to move in the downward direction. So that particular angle will be generally called as angle of repose. That particular angle is generally called as angle of repose. Next, the another important terminology what we use in case of friction is cone of friction. So cone of friction is nothing but if I apply the force P on an object which is having the weight W, the object will start to offer a frictional resistance. Friction will start to offer a friction. If you consider, and there will be a normal force here. If you consider the resultant of this, this resultant will keep on changing. Okay, this resultant will be in some direction. If you change the direction of force from this direction to this direction, your resultant is going to shift towards this side. Okay, so this, if you keep on changing the force direction, it will create the resultant force will create a cone. That cone is called as cone of friction. So these are some of the basic aspects that you need to understand in order to solve the friction. So here, very important one is, very important equation to be remembered is the frictional force. The frictional force F is always equal to mu times of N, or F by N is equal to mu. Okay. F by N is always equal to mu is equal to F by N. Okay. So when phi becomes small, tan phi is approximately equal to tan mu is equal to tan phi. So it is in the triangle, in this triangle, this is frictional force, this is normal force. If you apply the tan phi, it will be F by N. Okay. So this is how this equation is given. So you have to remember the frictional force is always mu times the normal force, where mu is the coefficient of friction. So there is one problem. A steel beam of 600 diameter rolls on the horizontal steel rail. It carries a load of 500 Newton. The coefficient of rolling resistance is 0.3. So this is nothing but they have given the mu and weight of the object is given as 500 Newton. So they have the force in N necessary to roll the wheel along the rail is dash. So we know that the total force P is equal to force P required is equal to mu times of N. Mu times of N, because here there is a wheel. The weight of the wheel is 500 Newton, right? It is 500 Newton. The weight of the wheel is 500 Newton. It has to move over a horizontal steel rail. It has to move over a horizontal steel rail. Whenever there is a contact surface between the two surfaces, there will be a frictional force component. So the coefficient of friction is given as 0.3. So we know that frictional force is always equal to mu times of normal force. So as per Newton's law, we know that for every action there is an equal and opposite reaction. So the normal force N will also be equal to 500 Newton. Okay, 500 Newton. So therefore, 0.3 times of 500 is 150 Newton. So that will be the answer for the problem 2. So in the next problem, a body weighs 625 Newton is lying on a surface on a rough plane incline at an angle of 30 degree. So the angle of inclination is given as 30 degree with the horizontal. It is supported by an force or an F. In case of this problem, they have called the force P as an effort parallel to the plane as shown in the figure. If the friction angle is 20 degree, so here they have given the friction angle phi. Phi is given as 20 degree. The minimum value of P from equilibrium condition will be what? So we need to find out the value of P in order to maintain the equilibrium. What is the minimum force P which has to be applied in order to avoid the movement of the object in the downward direction, that we have to determine. So for that we know that there is a 625 Newton force which is acting in the downward direction, which is a weight of an object. So we know that the normal force is always perpendicular to the surface. There will be force here, and the frictional if the body is inclined at a certain angle, the body will start to move in the downward direction. Move in the downward direction. So the frictional force will be in the upward direction. But in this problem, what we have to do is we have to find a force P such that body is not going to move in the downward direction. So body is not going to move in the downward direction means it is pulling in the upward direction. So if it is pulling in the upward direction means the frictional force will be acting in the downward direction. So in this type of problem, we will resolve the forces along the inclination. This will be our reference axis, x and y. Okay, x and y. If you consider x and y as a reference axis, so this force, normal force will be acting at an angle of 60 degree. How it is 60 degree? Since this is 30 degree, since it is perpendicular to this surface, it is 90 degree. 90 plus 30 is 120. So in a triangle, the sum of all the included angles in a triangle is 180 degree. So this will be 60 degree. So this force is acting at an angle of 60 degree with respect to horizontal. Okay, but we are resolving the force along x inclined angle x dash and y dash. Okay, along the frictional force and normal force. So what will be this angle? We know that this is the angle of inclination of the plane surface. Okay, this is with respect to horizontal, it is making an angle of 30 degree. So this angle will be equal to 60 degree. So if you resolve all these forces into x component and y component, this is the force. So if I write this force and write the reference axis at the tail end, it is in third quadrant. In the third quadrant, both the x component and y component are negative. So the component will be 6. This is 625. So x component will be 625. So this angle with respect to x-axis is with respect to inclined axis, it is making an angle of 60 degree. Okay. So I am considering it. This is 625 Newton force. The angle it is making with respect to this will be 60 degree. Right. So the x component is 625 cos 30 degree and y component is 625 sin 30 degree. Sorry, sin 60, cos 60 degree and sin 60 degree. Okay. So that is along x component means parallel to the tangent, parallel to the frictional force. So if I take the summation in sigma fx condition is equal to 0, or the force in the frictional force in the direction of friction is equal to 0, then it will be minus f minus 625 sin 30 degree or cos 60 degree, both are same, sin 30 degree, or you can take it as cos 60 degree. Minus sin 30 degree and cos 60 degree, and along with we require a force P. There is a force P which should be equal to 0. So that is the equilibrium condition. So net force in the direction of frictional direction should be equal to 0, or you can write P is equal to 625 cos 60 degree plus F. So what is frictional force? frictional force F is equal to always mu times of N. What is normal force M? Normal force M, if you apply sigma Fy is equal to 0 condition, you will get the normal force as 625 cos 30 degree or sin 60 degree. 625 sin 60 degree. So here the angle of friction is given. So tan phi is sorry. Phi is given as 20 degree. So tan 20 degree will be equal to your mu value will be equal to tan phi 90 degree. So if you apply it, solve it, you will get tan phi, since the angle is 20 degree, mu will become 0.36. So P will be equal to 625 sin 30 plus 0.36, 625 cos 30. So the force P will be equal to, if you resolve this, you will get 5.5 Newton. Okay. Coming to the last problem of today's discussion. This is as given in the previous gate, I think 2021 gate question. A wedge M and block M are subjected to force P and Q shown in figure. If force P is sufficiently large, then block M can be raised. The weights of the wedge and block are negligible compared to the force P and Q. The coefficient of friction mu along the inclined surface between the wedge and block is given as 0.2. All other surfaces are frictionless. The wedge angle is given as 30 degree. Okay. So in this problem, what they have did is they have used the wedge to lift the object. Okay. To lift the block M. In order to lift the block M, they have used the wedges. So when you apply a force P, as the wedge move in the towards the left, the block M is going to be lifted. So if you write the free body diagram of this diagram, so here they have given three surfaces: surface 1, surface 3, and surface 2. So what they have mentioned is surface 1 and 3 are smooth surfaces. That means for smooth surfaces, mu will be always equal to 0. So for smooth surfaces, the mu will be always equal to 0. For highly rough surfaces, mu will be equal to 1. So mu can vary from 0 to 1. So here, except this contact surface, all the contact surfaces are, they have mentioned as frictionless. Okay, frictionless, or they consider it as smooth surface. So in such a type of problem, you have to write the free body diagram of this entire system. So how to write the free body diagram? So block M is exerting the pressure on the wedge. So there will be a normal force on this inclined surface. So that is, let me call this as normal force M. As the wedge moves towards left, there will be a frictional force which resists the movement of wedge to the left. So the frictional force will be M. And they have given that the coefficient of friction is 0.2. So the frictional force will be 0.2 times of M. And there will be a horizontal reaction and what normal reaction. This is N1, this is N2. Okay, 0.2 times of N2, and this is N3. The frictional force in these contact surfaces are 0. So if you write the free body diagram of this, so first I will write the free body diagram of block M. So while writing the free body diagram, you should always consider the forces exerted by other object on that block. Okay, so there is a force Q here, there is a force Q. Okay, so they have asked us to find out the limiting force P in terms of Q required for impending motion of the block and impending motion means just to move. Okay, so as given as P is equal to alpha times of Q. The value of coefficient alpha is dash. That's what they have asked. So we have to represent, we have to find the value of P and Q, P in terms of Q, and then we have to find the alpha value. So for that, I am writing a free body diagram of block here. So there is originally there is a force Q and there is a normal force F3, okay, and there will be a normal force F2. So this angle of inclination is 30 degree, this angle of inclination is 30 degree. So this reaction will be acting at an angle of 60 degree. Okay. This will be acting at an angle of 60 degree. And if you consider the if you consider this object, block M, the wedge is moving to the left, so the relative movement of the block M is towards right, so the frictional force will be towards. You have to consider the frictional force. You have to consider the always relative motion, so your frictional force should be equal to 0.2 for block M. If you write the free body diagram of a wedge, there will be a normal force F1, the frictional forces are 0. Since the object is moving towards left, this frictional force is 0. Okay. The object is moving towards right, left, the frictional force should be considered towards upward. So this is 0.2 times of F2. 0.2 times of F2. Okay, and this block M is going to exert a pressure that is equal to F2. If you simplify, if you apply sigma Fx for this block condition, so if you apply sigma Fx is equal to 0 for wedge portion, it will become minus, so there is a force P here. So there is a force P here. There is a force P here. If I apply sigma Fx is equal to 0 minus P, and if you resolve this force into horizontal and vertical component, it will become point minus P plus point frictional force is 0.2 times of N2. Since it is acting at an angle of 30 degree, the horizontal component is cos 30 degree plus normal force is acting in the fourth quadrant. The x component is N2 cos N2 cos 60 degree. This should be equal to 0. So if you simplify that, you will get the value of N2 as 1.49 times of P. Okay. Now apply the sigma Fx condition. Apply the sigma Fx condition for the block. Sigma Fy is equal to 0 equation. I will apply sigma Fy is equal to 0 for block L. So force Q is acting in the downward direction, so minus Q, then a component of this normal force is acting in the upward direction, that component will be equal to, if you N2 cos 60 degree, N2 cos 60 degree. So since N2 is nothing but 1.49 times of P, you can consider it as 1.49 times of then uh, the frictional component force is 0.2 times of 0.2 times of n 0.2 times of n2 sine 30 degree. Sine 30 degree. So if you simplify that, you will get the value of Q as Q is equal to 1.141 times of P, or P by Q you will get it as 0.87. So the correct answer is 0.9. So this is how you have to solve the problems related to frictional forces. That's how we have to solve the problems related to frictionals. So probably I will stop at this stage. Thank you. We will meet on the next session related to concrete structure. Thank you.